Good day. Welcome back to our last session on grade 11 probability. If I can remind you, the first topic that we discussed within this probability chapter was on rules of probability. Then secondly, we looked at Venn diagrams, 2 events as well as 3 events. Then the third topic we did was the two-way contingency tables. Now we are at the last topic, very exciting, tree diagrams. I want to say right from the start, tree diagrams got nothing to do with the topics we did before. So the and or and all those rules that we used in the previous lessons is not applicable on tree diagrams. Tree diagrams are the introduction into conditional probability. Conditional probability is not in our syllabus. We only do tree diagrams. I would like to discuss a few questions with you. The first two are fairly easy, just to have a good understanding how we approach this, and then we will look at two that is a little bit more exciting. So let's go for the first one. In this first example, I say this is drawing with replacement. So it's just to mention up front what we would like to see. Now, what we mean by this replacement, you will understand now when we read the question. I say a bag contains 6 red balls and 4 blue balls. A ball is chosen and the color is recorded and the ball is replaced. It's placed back. So it means the total number of balls, which is 10, will not change because of the fact that we replace. A ball is chosen again and the color is recorded. What is the probability of choosing 2 balls of different colors? Don't worry about the question now yet. We first want to do our tree diagram, and then we will look at the question, what they exactly want. So there are 2 events, and the 2 events is the first draw and the second draw. So I draw my first 2 branches, and this one we can say is red, and this one is, let's write it down, blue. So the question is, what if I select or draw a ball from the bag? What is the probability that it will be red? So, like we said many times, how many red balls and what is the sample space? Because we want probability. And you will agree with me, it is 6 red balls with a total of 10. So that is 6 over 10. Now we do the same for the blue. How many blue balls? 4, and the total is 10. It is very important to remember that this probability plus this one must always add up to 1. If they don't add up to 1, you've made a mistake somewhere. That is always your test. So this represents the first draw. So now I want to go to the second draw. Now it's very important now. If I want to do the second draw, that is then based on whatever happened in the first draw. So this can be red or blue. Or if the first one was blue, this one can be red or blue. So what does this mean? It means that we're not saying that the first one was definitely red. We say on condition that this one was red. What is the probability the second one will also be red? But you will remember we replaced. So I hope you agree the probability will stay the same. And that is the key. When we replace, the probability doesn't change because the sample space stays the same. And therefore, this will be 4 over 10. And now On a similar way, on condition the first one was blue, what is the probability that the second one will be red? So how many red ones? Still 6 over 10. And for blue, how many blue ones? 4 over 10. And every time the two branches, those two and those two, every time they add up to 1, as you can see. Always remember to write down your outcomes next to your drawing. It's very important that examiners must see this. So I'm just going to write it down in short. And I'm going to say my first outcome is red and red. So red on the first, red on the second. So that means the two colors are the same. The second outcome is red, blue, red and blue. And then if you look at, we go now for the blue part, we go blue and red, and then blue and blue. So we go blue, red, and blue, blue. And there we are finished with our tree diagram. So now we are ready to answer the question. And the question is, what is the probability of choosing two balls of different colors? And that is important, but that is because that's what they ask for. Now, you look at your outcomes, red and red, same color, blue, blue, same color. So I think you will agree with me, we are looking for those. So we're going to say the probability of red, blue, plus, if there's more than one, we always add the answers, plus blue, red. And now we must find this probability. Now, to find the probability of red and blue, we follow those branches. So it's 6 over 10 multiply by 4 over 10. So this one will be 6 over 10 times by 4 over 10. I'm just going to put it in a bracket so that it's not looking too confusing. Now I'm going to do the same for blue and red. So blue, red, it's 4 over 10 times 6 over 10. And then we say 4 over 10 times 6 over 10. And now we multiply, which is fairly easy to do. And then we write down the answer. So this will give us 24 over 100 plus, there we also get 24 over 100 if I multiply, which will give us 48 over 100. And you can see we can take this to a decimal, or you can just simplify it as a common fraction, and that is 12 over 25. And that is the probability that when you draw two balls, one after the other, that they will be of different colors. And that probability is 12 over 25. Let's now look at the second example. This example is almost the same as the first one, but with the difference that there is without replacement. So that means once we draw the first ball, we don't put it back, we just draw a second one. So let's start with this diagram. So it's again going to be red and blue. And it's still the same number. So for red, it's 6 over 10. For blue, it is 4 over 10. But now on condition the first one is red, this can be red or blue. And if the first one was blue, then it can be red or blue. And this is now where you must be very, very careful, because there was no replacement. So that means now that the probability here will not be the same as this one. Because now it's very important to understand how to think about it. It goes like this. On condition the first one was red, what is the probability the second one will be red? So on that condition, now it means there's one lesser red ball because we didn't replace. So I hope you agree with me. We're going to get 5/9. There's only 9 balls in the bag, not 10 anymore. And then for blue, because the number of blue balls are still the same, and that is 4/9. And as you can see, that this 5/9 plus 4/9 equals 1. And that is what it's supposed to be. So we are confident we are correct. So on the next one, on condition the first one was blue, what is the probability the second one will be red? So that means the number of red balls still 6, but the total or the sample space is 9. And now for blue, because it's on condition the first one was blue, so that means one lesser blue ball, which is then 3/9. And now we're going to write down our outcomes again, like we did in the previous one. It's red, red, red and blue, and this is blue, red, and this is blue and blue. So there's our tree diagram now, and we're now ready to answer the question. And the question say, what is the probability of choosing 2 balls of the same color? Now, on your outcomes, where do you find the same color? And I hope you agree it's red, red, and it's blue, blue. So I'm just going to indicate that so that we know which ones we're going to calculate. So now we're going to find the probability of red and red plus the probability of blue, blue. So now, probability of red, red, we're going to multiply 6/10 by 5/9 because that is red, red. So we say here 6/10 times by 5/9 plus, and now we go for blue, blue for this one. Now, I erase this one, so let me just put it back there. It doesn't look nice. So let's just write down blue, blue. And now I want to follow those branches of blue and blue again. So we're going to take the 4/10 and multiply it with 3/9. Now, this you can do on your calculator, or if you are brave enough to do it mentally, it's also okay, because 5 times 6 is 30, 10 times 9 is 90, plus 4 times 3 is 12, and 10 times 9 is 90. And you can see we get an answer of 42/90, which is definitely possible to simplify, and it simplifies to 7/15. So that is the probability that the 2 balls will be of different colors. So I hope you understand the difference between the 2 examples. In the first example, there was no replacement. Sorry, it was replacement. I repeat, the first one said we replace, and in the second one, there was no replacement, without replacement. It's important to understand the difference. So the easier one of the 2 is when we have replacement, because probabilities stay the same. And this one, a little bit more exciting and very popular in exams as well. Let's now move on to another one, which is a little bit more exciting. So let's look at this example. I call this one conditional outcomes, and I will show you later why. So I say Lindiwe either walks to school or she takes the bus. If it rains, there is a 30% chance that Lindiwe will walk to school. If it doesn't rain, there is a 90% chance that she will walk to school. According to the weather forecast, there's a 40% chance that it will rain tomorrow. What is the probability that Lindiwe will walk to school? Now, when we read this question, you will agree it sounds very, very confusing because it's not clear where we need to start. Now, that is the first thing I would like to explain. So, my first branches, because this is about walking to school or taking the bus, but then it's also about the weather, if there's rain or no rain. So the big question, which one of those are first? And that is where the name comes in of conditional outcomes. Which one is on condition of which one? Will she first decide on what mode of transport she's going to use? Either she's going to walk or take the bus, and then we look at the weather, and you will agree it doesn't make sense. The weather determines how she will get to school. So we need to start with the weather first. And that is really important. That is always in these questions where you need to start. So I'm going to say maybe there's rain or no rain. Now, what is the probability for rain? So let's have a look. They say here in this sentence, according to the weather forecast, there's a 40% chance that it will rain. So now that 40% chance, and I'm going to take it to a decimal, is 0.4. Take note, they did not say anything about a probability for no rain, but it's not necessary because remember what I said before, these branches must add up to 1. So the moment one of them is given to you, we can immediately write down the other one because they must add up to 1. So now we're going to continue. And now we're going to say, on condition that there's rain, she will think of walking to school or taking the bus. If there's no rain, she can either walk to school or take the bus. And now we must do those probabilities. So now we need to look at our information because we are at rain. If it rains, what probability was given to us? And that sentence you can see. If it rains, there's a 30% chance that Lindiwe will walk to school. So if it rains, 30% chance. So I hope you're happy with 0.3. And of course, this one out immediately 0.7. You don't even need to look for it, but it was not given to you either. And they, as you can see, add up to 1. Now for the no rain. And that is where you will see in this sentence. If it doesn't rain, there is a 90% chance that she will walk to school. So walk to school is 90, so it's 0.9, and taking the bus then is 0.1. And now you can see that this was not too bad. The important thing was to know where to start. So we're now going to write down our outcomes, and this is rain, walk, and this one is rain and bus, and this is no rain, walk, and no rain, bus. We may just put a comma in between. All right, and there we are done with our tree diagram. So now for the question. What is the probability that Lindiwe will walk to school tomorrow. Now, when they say here, walk to school, it doesn't matter. They didn't say anything about the weather. So that means we don't care about the weather. We only want to know when she will walk to school. So that means we want those ones. So because she walked to school, if it rains, she walked to school if there's no rain. And the question is, we want the probability that she will walk to school. And those are the two that we're going to calculate. So I'm going to start off by saying the probability of rain, and I'm just going to use the first letters, rain and walk, plus the probability of no rain and walk. And now we do the same, we multiply the branches. So for this one, I'm going to multiply 0,4 by 0,3, the rain and walk, and that is the 0,4 times 0,3. And then I'm going to add to that the next one, which is no rain and walk, and it's 0,6 times 0,9. And that is 0,6 times 0,9. Again, if you want to use your calculator, I just want to fix that one a little bit. And then it's not too difficult, because if we multiply this, we get 0,12. And if we multiply that, we get 0,54, I think. And if I add those two answers, that will give me 0,66. Now, please take note what we said in previous lessons, that whenever probabilities are given to you in percentages, we take them to decimals so that we can do the calculations, but now we will give it back in a percentage. So that's 0,66. You agree with me, it will be 66% chance that she will walk to school, irrespective of the weather. I hope you agree, a very exciting little question. Let's go for the last example. In this example, we have the following. In a town, if it rains on a particular day, the probability that it will rain on the next day is 40%. If it doesn't rain on a particular day, the probability that it will rain on the next day is only 10%. If it rains on Monday, what is the probability that it will also rain on Wednesday? So the first thing I want to do is I want to say we start with Monday, because it's Monday, Tuesday, Wednesday, and we look at our first two branches. And what will this be? This will be rain or no rain. Now, on Monday, they told us it will rain. So this is now what happens on Tuesday. So let's go back to what they said to us. They said, if it rains on a particular day, that is now Monday, what is the probability it will rain on the next day is 40%. So I hope you agree that I'm going to say the rain on the next day is 40%. So it rain on Monday, there's rain on Monday. So for it to rain on the next day is 40% or 0,4. Now, the common mistake in this question is that people get confused, because there we say if it doesn't rain. So now they think of the no rain, and that 10% they want to put here. But you agree with me, they're not going to add up to 1. So that 10% it's got nothing to do with this no rain. Remember, we only need to have one of them. This one we can write down because they must add up to 1. So that one is 0.6. And now we go for Wednesday. Remember, Monday there was rain. On Tuesday, there was a probability for rain or no rain. And for Wednesday, there's a probability for rain or no rain. And if there's no rain on Tuesday, Wednesday may have rain or no rain. So let's now see, because we need these probabilities now again. So on Tuesday it rains. So what is the probability it will rain on Wednesday? And now we look at this one. The probability that it will rain on the next day is 40%. So this will be the same as this one, because there was rain on Monday. So for rain on Tuesday is 40%. For rain on Wednesday is also 40%. 0.4, so that one will be 0.6. If we now look at the no rain, and that is where we have this sentence. If it doesn't rain on a particular day, and remember, on Tuesday, no rain. So if it doesn't rain on a particular day, the probability that it will rain on the next day is 10%. So if it doesn't rain today, which is now the Tuesday, probability for rain the next day is 10%. So that means 0.1. So for no rain, 0.9, because they must add up to 1. And as you can see, there we have our tree diagram. I'm just going to write down the outcomes. So I'm going to say rain, rain, rain and no rain. And I'm going to say no rain and no rain and no rain. So that is our complete tree diagram. So let's look at the question. Question asks us for the probability that if it rains on Monday, and that we used, we said here it rains on Monday. If it rains on Monday, what is the probability that it will also rain on Wednesday? So they don't really care what happens on Tuesday here. We want to know what is the probability it will rain on Wednesday. So it is rain on Wednesday. Remember, this represents Wednesday. So where do we have rain on Wednesday? And you agree we have it here, because you can clearly see there's rain on Wednesday and there's rain on Wednesday. So we want to work out those ones. So now we do it the same. So I say the probability of rain, rain, plus the probability of no rain and rain, and we're going to multiply those branches. So for rain, rain, I'm going to multiply 0.4 and 0.4. So 0.4 times 0.4, and I'm going to add it to, and I'm going to, for this no rain and rain, I go no rain 0.6, rain 0.1. So I go 0.6 times 0.1. And we can now easily calculate this. 0.16 plus 0.06, which will give us, when we add them, which will give us 0.22. So for rain on Wednesday, we can now say, so therefore, there's a 22% chance for rain on Wednesday. That is our last problem on tree diagrams, also our last lesson on grade 11 probability. To understand this well, do more problems similar to the ones we discussed. All of the best. Thank you.